This is a continuation of lesson 6.3, which is proving that quadrilaterals are parallelograms. Now, we've talked about several different ways of doing that, and this is going to be coordinate geometry. That means that they're going to give you numbers that represent the vertices of the parallelogram. It's on a grid, and we're going to use the vertices to demonstrate that the quadrilateral is a parallelogram using the theorems that we've discussed in this lesson. So there are several different ways to do this using formulas, and I'm going to show you different options, okay? If I gave you this problem and said, prove this is a parallelogram, you could do just method 1, and that would be a complete solution. Or you could do method 2, and that would be a complete solution. Okay, I'm giving you all the different options, and so I want you to understand how to do it all the different ways because something might be easier to you than others. Okay, so the first method is we're using the theorem that says that if a quadrilateral has two pairs of opposite sides that are parallel, then the quadrilateral is a parallelogram. Okay, so this is going to be if quad has two pairs of parallel sides, then it's a parallelogram. So if you're trying to show parallel, you use the slope formula. So we need to make sure we know the slope formula. Slope is y2 minus y1 over x2 minus x1. Okay, so we're showing that both pairs of opposite sides have the same slope. That means we're going to have to do the slope 4 times because we need to show that these sides are parallel, and then we also need to show that these sides are parallel. Okay, I'm going to do my calculations up here beside the picture and then copy it down below because I feel like that'll be easier than scrolling back and forth. Okay, so the slope of segment BC, 5 minus 1, change in y, over change in x. Remember, the order has to be the same. So if I start with point B for the y, I have to start with point B for the x. Okay, that's 4 over negative 6, which is negative 2/3. Okay, and then the side that it's supposed to be parallel to, the slope of segment AD will be 3 minus negative 1, or 3 plus 1, over, we're using these 2 points, 1 minus 7. 4 over negative 6, same answer. Okay, because the slopes are the same, that means that those lines are parallel. So we just showed that these two sides are parallel. Okay, so this shows you that BC and AD are parallel. All right, we're going to do the slopes of the other pair of opposite sides. So the slope of segment AB, change in y is 5 minus 3. Change in x is 3 minus 1. 2 over 2. That slope is 1. Okay, slope of the opposite side, slope of AB, that would be, AB should be parallel to CD. So the opposite side, change in y is 1 plus 1 over 9 minus 7. 2 over 2 is also 1. Move that down here. Okay, and that demonstrates that segment AB and segment CD are parallel. So that demonstrates that segment AB and segment CD are parallel. You could have also done the slope by counting up 2 over 2. So you can double check yourself that way. But when you're doing coordinate geometry, you're expected to do formulas. Now, since segment AB and CD have the same slope, they are parallel. And then because BC and AD have the same slope, they're parallel. And then I kind of would rather this say because two pairs of opposite sides are parallel, ABCD is a parallelogram. Okay, this method is using the theorem that says that if a quadrilateral has two pairs of parallel sides, then the quadrilateral is a parallelogram. By the way, when you graph, if it tells you ABCD, even if you didn't put this on the picture and you just came over and said, I'm going to make myself a sketch, when you go to label the vertices, remember they have to go in order. So it can't be A, B, C, D. It's got to go in order. So even if you're not plotting the points, A, B, C, D like this, or A, B, C, D like this. Now it doesn't really matter where you place A, but you've got to go in consecutive order around. Now on this problem, we have the grid there, but I'm just saying if you did not take the time to actually plot the points and you're just making a sketch to think through it, it's super important you get the points labeled correctly, because otherwise, if you, for example, put A there and B there, when you do the slope of segment AB, you would actually be finding a diagonal slope, not a side slope. Okay, that's a really common mistake. Don't be that person. All right, method number 2. Again, these are options. I'm not typically going to ask you on a quiz or a test to do multiple ways. So I might give you the option of how to do it, or I might say show, that it's a parallelogram with this method. Okay, so this is using that if a quad has two pairs of opposite congruent sides, then it is a parallelogram. Okay, so if you're trying to show congruent, that means you want to show they have the same length. Same length means which formula? Well, that means distance. If you don't remember the distance formula, you got to get it in your head. Square root of the difference in the x's squared, x2 minus x1 quantity squared, plus the difference in the y's, y2 minus y1 quantity squared. Get the whole thing underneath the radical sign. All right, I'm going to come up here and do distance again. This will be a good time. 4 distances. AB is the square root 3 minus 1 squared plus 5 minus 3 squared. Again, I'm doing x2 minus x1 and then y2 minus y1. So that is the square root of 2 squared plus 2 squared, which is the square root of 4 plus 4. Make sure you're following order of operations. You got to get down to a single number before you can add them together. Two single numbers before you can add them together. And then remember, that's a square root that breaks down. It'll become a 2 root 2. So 8 breaks down like 4 and 2, and then 2 and 2. A pair of 2's come out, 1 stays inside. Or you can just think square root of 4 times square root of 2, which is 2 square root of 2. Just a little refresher there on breaking down radicals. Okay, so there's AB. Let's grab that and move that down below. There's AB. This is so much nicer doing it on an iPad than on paper. I love we can adjust things well. Okay, so this was 2 root 2. Now BC. Actually, I'm going to go ahead and do the opposite side because that's supposed to come out to be congruent. So I'm going to go ahead and jump over the opposite side. So the length of segment CD means just CD without the bar over top of it. Okay, so the change in the x is 9 minus 7 quantity squared, and then 1 minus negative 1, or 1 plus 1 quantity squared. So 2 squared plus 2 squared. Hey, look at that. 4 plus 4, same numbers, so it'll also turn out to be 2 root 2. And again, reminder that we knew on this problem that it's supposed to be a parallelogram, so it better come out to be the same as the last one, the opposite side. If it didn't, something's wrong. Okay, I'll stick that right there. I'm going to notice that these lengths are the same, and that will tell me that AB is congruent to segment CD. Okay, segment AB and segment CD are congruent. All right, I'm going to do the same thing on the other pair of opposite sides. Okay, the next one says segment BC is the distance we're looking for. So we've got change in x is 9 minus 3 quantity squared, plus change in y is 1 minus 5. Now remember that when you're doing distance formula, if you start with 9 for the subtraction, you actually don't have to start with 1 for the y's. You can start with the other one, because when you square those values, it'll take care of the negative sign. With slope, the order matters. With distance, you just have to make sure you group x's and you group y's. So this is 6 squared plus negative 4 squared, square root of 36 plus positive 16 is the square root of 52. Okay, square root of 52 is 4 times 13, so that'll be 2 root 13. So this side's 2 root 13, and the other one better turn out to be the same. Okay, then the last side. This is clearly a long process. It was easier to do 4 slopes than 4 distances. Okay, the length of segment AD, square root of 7 minus 1 squared, and then again, it doesn't matter the order. I'm going to go ahead and do 3 plus 1 on this one just to show you it doesn't matter. Okay, square root of, that'll be 6 squared, and that'll be positive 4 squared. It ends up being the same as negative 4 quantity squared, so it's still going to be 36 and 16. It's still going to be square root of 52. It's still going to be 2 root 13. All right, so these turned out to be both 2 root 13, and that means that we have proven that this is a parallelogram by showing that the length of both pairs of opposite sides is the same. The 2 pairs of opposite sides are congruent. Again, here is the theorem that we're using. If a quad has 2 pairs of opposite congruent sides, then it's a parallelogram. So this, we just showed that segment BC is congruent to segment AD, because we did the distance formula. And then because both pairs of opposite sides are congruent, that makes the quad a parallelogram. Okay, method number 3. Show that one pair of opposite sides is congruent and parallel. Now again, this is another option. We've already done the work to show congruent and parallel, if you were starting this from scratch, you would have to pick a pair of sides and then show that pair of sides is congruent by doing distance twice on those opposite sides 2 times, and then show they're parallel by doing slope 2 times. Okay, there'd be 4 calculations, but it would be 2 slope formulas and 2 distance formulas. Now, we have already done the calculations, so I'm not going to make you do that over again because we already know what those lengths are. A, B, and C, D are the sides they chose. Okay, they picked A, B, and C, D are both 2 root 2. And their slopes are both 2. No, are both 1. Right, up 2 over 1. Sorry, their slopes are both 1 because it's up 2 over 2. Their slopes are both 1. So that means that this pair of sides are parallel and congruent, and therefore that's a parallelogram. Okay, this is the theorem that you're using. If a quad has one pair of opposite sides that are both parallel and congruent, then it's a parallelogram. Okay, that's the theorem that we're using here. If a quad has one pair of opposite sides that are both parallel and congruent, then it's a parallelogram. Now, again, we've already done the work, so we know the slopes are we know the slopes are both 1 and the lengths are both 2 root 2. So A, B, and C, D are parallel and, actually I'm going to say it the other way around, are congruent by doing distance twice and parallel by doing slope twice. Therefore, it's a parallelogram. Okay, and then the last method is, again, these are options. Show that the diagonals bisect each other, which means they have the same midpoint. So again, if a quad has diagonals that bisect each other, then it's a parallelogram. So we're going to show they have the same midpoint, which means we need the midpoint formula. Midpoint formula is the one that goes average the x's, so x1 plus x2 over 2, and then average the y's, y1 plus y2 over 2. Okay, so I'm going to come up here and do the midpoints of the diagonals. Midpoints of the diagonals. All right, so we've got one diagonal is segment AC. Midpoint of segment AC is going to be 1 plus 9 over 2, and then 3 plus 1 over 2. 5, 2. And that seems reasonable. That's the midpoint, right? Now let's also calculate the other midpoint because we're trying to demonstrate that using algebra, using formulas, calculations, I don't know if it's really algebra, that the midpoints are the same. So 3 plus 7 over 2 and 5 minus 1 over 2. Okay, 10 over 2 is 5. 4 over 2 is 2. They have the same midpoint. If a quadrilateral has diagonals that share a midpoint, then that means that the quadrilateral is a parallelogram. Okay. Diagonals AC and BD share a midpoint, or here, I'll say it this way, have the same midpoint. So ABCD is a parallelogram. Let's do a quick summary. So your options are show 4 slopes, or 4 distances, or 2 slopes and 2 distances, or 2 midpoints. If I have the option, I'm going to go with this one, right? That's the easiest one. Shortest, easiest, no square roots involved. I'd go with that one. This is the end of the lesson.